In this section, we're going to come up with some equations for parabolas, and we're not going to look at pictures, but we're just going to be given some different things. In each of these, you get something different, like the vertex and the directrix, the focus and the vertex and the directrix. Those kind of match together, and a vertex at any point on the parabola. So let's take a look at this. Number 3. Here's what we are going to do. For these kinds of questions, we're going to imagine what this looks like by drawing just a quick and simple sketch. Positive 4, negative 6 is somewhere down here. And the directrix is x equals 3. So if this is 4 to the right and 6 down, then 3 to the right would be a line, a vertical line that's to the left of that point. That's all I really need. I do want to maybe label this as V, so for vertex instead of F for focus. If this is the vertex and that's the directrix, your directrix is vertical, that tells me that it's not going to open up, it's not going to open down. Your parabola will never intersect the directrix. Your directrix is always away from the direction of your parabola. So that means it either opens left or opens right. Now if it opens left, it's going to contact the parabola, which means there's only one option, that this parabola is opening to the right. What we can do is figure out two things. We need to know the general formula, but then be able to adjust it to compensate for our vertex not being at the origin, which it always has been so far. The first thing I want to do is let's measure the distance between the vertex and the directrix. From the vertex to the directrix, from positive 3 to positive 4 is 1 unit, which means our focus is also 1 unit away to the right. So our focus would be the point then 5, negative 6 if we needed to identify it. What we do need to identify is our value for p. Our value for p is positive 1 because, again, opening to the right is a regular direction for a parabola with the equation 4px equals y squared. That's our general equation because, again, we know that it's opening to the right. So 4px equals y squared. We know our p-value, so we can go ahead and plug that in. 4x equals y squared. Now, this equation would have the same distance to its focus and its directrix, but its center is the origin. What if we want to translate this 4 units right and 6 units down? We can rely on the thing that we learned early in the year. How do we move any sort of graph? If I want to translate something 4 to the right, I'm going to take the x-coordinate, put a parentheses, and subtract 4 to that x-coordinate. And if I want to move something 6 down, I'm going to add 6 inside a set of parentheses to the value of x. Now this formula is considered completed. This is a 4px equals y squared formula. So it tells me where the vertex is. It's not 0, 0, as we saw at the end of our first video. If we change the vertex to hk, we can do that by adding and subtracting the x and the y coordinates of your new vertex. And this would be the value 4p. 4p equals 4, or p equals 1, which tells me it's going to open to the right. Double check that the y is being squared, not the x. That's how you can complete something like question 3. And then 4 through 6 is a variation of this. Now 5 is very similar to 3. I'm going to come back to that. Let's take a look at number 4. Here's a focus and a vertex. Since they have the same x-coordinate, that means they're to the right or to the left and then on top of each other, which means I think this is going to either open up or open down. Let's do a little bit of sketch. Negative 5, 3, negative 5, 7. I'm going to put the letter F here and the letter V there. Okay, now this tells me a lot. Because the vertex is up here and the focus is down there, that means our parabola is going to open down. Your focus is always inside of your parabola. That tells us it opens down. Now because it opens down, the general equation is going to be 4py equals x squared. So we're going to begin with that. The value of p is the directional distance from the vertex to the focus, and that looks like it's 4 units. However, it's 4 units down. This tells me my p-value is negative 4, unless you're doing a delta math, and then they want to know that you're taking the absolute value of this p-value when you go do your homework. But for me, I never make things easy. We are going to use a negative value for this value of p in this case. So we got this. We got negative 16y equals x squared. Now this would again have a vertex at 0, 0. We want to shift it left 5 and up 7. So what's going to make it go left 5 is we're going to add 5 to the coordinate of x, and we want it to move up 7, so we're going to subtract 7 from the coordinate of y. And then this is your completed finished formula for this exercise. Yes, you could solve this for y. It does take a couple of steps. You'd multiply by negative 1/16, and you'll add 7. I mean, we could, if you wanted me to, y equals negative 1/16 times the quantity x plus 5 squared, and then that would free up our 7. We're going to add its opposite, plus 7. Now that's a vertex form. That's from way back when in chapter 1. I guess that was fun to do. Let's do this one. Let's multiply by 1/4, and then we're going to add a 4 to solve for x. Because you reverse order of operations, you're going to undo your multiplication and undo your parentheses. Let's undo that multiplication. Let's multiply both sides by 1/4. And then that parentheses has a -4, so we're going to add 4 to both sides. All right, that's not too bad. You could try to input either one of these two equations when it comes time to write your equations in Delta Math. Let's see which one it takes. I have a feeling it's going to take either one. If I'm wrong, then you'll see how you can do that. All right, number 5. Sketch a little sketch. 1, 4. Now your directrix is 5/2 or 2.5. It's a y equals equation. That means horizontal. 2.5 is under 4. Again, your directrix will never come in contact with your parabola. If this is your vertex, that means it can't open right, it can't open left, or else the parabola will hit the directrix. It could open up and it cannot open down, so therefore it's got to open up. 4py equals x squared. This is our traditional way. What's the distance between the vertex and the directrix? The distance is 1.5 units in absolute value. Because this is facing upwards, your focus has to be 1.5 units above. Because it opens up, our p-value is positive. Let's plug 1.5 in for p. So we have 6y equals x squared next, and finally we're going to move the vertex 1 to the right and 4 up. 4 up, 1 to the right. Again, if you would like to solve for y and get this into like a vertex form, I have a little bit more room than the ones above it, so I'm going to do this in 2 steps. I'm going to multiply by 1/6. That undoes the multiplication. Let's undo the parentheses by adding by 4. That's not too bad. Our last exercise on this page, let's see. This one we can do a little bit of a sketch. 1, -2 is down here, and it says a point on the parabola. Now it doesn't say what it is, but it's a point on the parabola. Okay, challenge accepted. 4 to the right and 5 up. Oh my. Okay, now here's the thing. This is purposefully vague. If this is your vertex and this is some point, now it's up for you to interpret that there are 2 answers to this. I can believe if this is the vertex, it could open up to contain that point, can't open down, or it can open right to contain that point, it can't open to the left. So if I believe that it opens up, this could be our parabola, or if you believe that it opens right, we get a parabola that looks very different. So let's pick one of these directions to work on first. Let's try to do up. So if it's up, that means 4py equals x squared. Okay, we know the vertex, we don't know the p-value, and we know the point is 4, 5. All right, let's see what we can do. 4p, let's insert that vertex. Y plus 2 equals x minus 1 squared. All right, if I need to find the value of p, the only other thing that I have is an x and a y coordinate of the point. I am able to substitute the x and the y coordinate to identify our value of p. 4p equals 5 plus 2. 4p times the quantity 5 plus 2. I think I said equals. It doesn't make sense. But that equals 4 minus 1 squared. Let's do some simple math. 2 more than 5 is 7, times 4 is 28, so 28p equals 4 minus 1 is 3. 3 squared is 9. That gives you a p-value of 9 over 28. So our equation could look something like this. 4p y plus 2 equals the quantity x minus 1 squared. We would simplify this. 4 goes into 28 7 times. So that coefficient would be 9 over 7. 9 over 7. And this would be your equation. You can keep multiplying things like this and you can manipulate it again. That's if it opens up. If you believe that it opens to the right, we can try to squeeze that in here. 4px equals y squared. Again, we're going to insert the vertex. 4px quantity minus 1 equals y plus 2 squared. Plug in the point 4 and 5. 4p 3 7 squared. So 49 equals 12p. P equals 49 twelfths. Now if I plug this in, so if I do 4 times 49 divided by 12, that's 49 thirds. Then I'll do the quantity x minus 1 equals the quantity y plus 2 squared. So these are both of the answers depending on whether you believe it opens up or opens to the right. There's two ways of doing this exercise, and not many questions will be open to your interpretation, but sometimes they might be. I'm going to actually add something to your notes, an extra page of practice, so there will be one more section in tonight's video, or today's video.